Good evening. Welcome to the Peptide PhDs. You know, Dr. Allen, sometimes I just sit back in amazement at what the human body can do. And, I was talking earlier about, in one of the previous podcasts, about the Winter Olympics.
Mhm.
And those athletes, like, doing amazingly, like, things that seem to make the body, I don't know, it seems impossible, right? Snowboarders flying through the air, spinning, flipping, landing perfectly on the board, right? Did you get to watch some of that?
Yeah, it just blows my mind how much bodily control some of these guys have, Dr. Mark. It's unbelievable to watch the athleticism that comes out of some of these athletes. It's crazy.
Yeah. I mean, the speeds that those downhill skiers had. So the level of focus and concentration, like figure skaters launching themselves into multiple rotations. I don't
Mhm.
know. It seems to me like every year the feats become even more extraordinary.
Yeah,
So is it
they
just me,
do.
or are humans somehow becoming more physically and even more mentally capable every year?
No, I think that they work so hard to just stretch the capability of the human body. And every year they try to add another flip off the ski jump or, the aerial aerob or what do they call that? Aerial ski, jumping where they
Mhm.
come up and they do all these flips and tosses and turns and twists. And my gosh, you just sit there and watch that or how they're the snowboards, they do in that half pike snowboard. And it's amazing what those guys can do. And you gotta sit there and ask, is it training? I mean, is that what it boils down to, or is it their mindset? Do they just believe more, Dr. Mark? I
I'm
mean, what do you
thinking
think?
I'm thinking mindset has a lot to do it. In a previous podcast, we talked about that. If you guys watch the downhill and the slalom, and you saw those guys, I don't think I'd seen footage of that before, where they sort of go through the motions. You can see them with their eyes closed, maybe their
Mhm.
headphones on, and their arms are moving. They're going through every single turn. I know that sports psychology has become a big thing. So maybe it's the marriage of the brain and the body there, that mindset.
Yeah, it may be. It's pretty amazing to watch them because it's like they memorize every single turn in that, and they visualize. And, visualization, I mean, we've been using visualization in sports for years and years and years because we know that when you visualize, for example, in football, our defensive line coach used to have us visualizing how to do a swim move or how to
Mhm.
do, some type of a move on an offensive tackle that we watched film on, and we've sat there and watched this guy get beat off of this move and this move and this move. And so you just sit there and visualize yourself doing that. And it's amazing how that, you know, can manifest itself in reality when you sit there and watch yourself. It's crazy.
Yeah.
So
What about nutrition? Do you think nutrition has become better over the years, and that's what sort of led to this sort of incredible advancement in sport achievement?
absolutely. I think nutrition is a huge part of it. We're eating so much better. We know now that, uh, I mean, you go back to, like we talked about a couple of weeks ago, 50 years ago, we were transitioning to this diet of, where we thought that ultra processed foods were heart healthy and so forth. Well, we find out that that's not really the case. We know it's whole foods and as close to a whole food diet as we can possibly eat because more natural the diet, the food is, the more available, in my opinion, the more bioavailable those nutrients are. And it's those nutrients that make so much difference. So,
Yeah. Well, maybe by now our listeners are starting to wonder, what are these guys rambling about? Where are we headed today? Well, let me tell you, It boils down to one thing, I think. It's about energy.
Mhm.
It's
Yeah,
about
I agree, Dr. Mark. Energy is it.
yep,
So
physical energy, mental energy, cellular energy, the ability to create it, to use it, direct it.
yeah, and maybe the question that some of us are asking is, how do these people have the energy to do what they do? I mean, golly, especially when I'm in Utah, I have a hard time just climbing the stairs, when it's at that 6,000-foot elevation. And these guys are doing this, Dr. Mark, at what, 10, 11, 12,000 feet elevation sometimes. It's
Mm,
nuts what they
y-
can do.
Yeah. So, and today at the Peptide PhDs, we're going to be talking about energy. We're going to talk about how your body generates it, how your cells make it, and strap yourselves in for that one because we're going to talk
Mhm.
some biochemistry, but we're going to make it fun and easy for you. Um, how your muscles use it. Then
Yep.
I think Alan's going to be doing a lot of talking there, right? How
Yep.
your brain perceives it, like what's happening when you feel like you have energy, and what's happening when you don't.
Yeah. And Dr. Mark, here's a really, really important question that we're going to answer today as well. Does energy have to decline with age? And I'm
Yeah,
going to say that the answer to that is going to be, well, sit back and watch. You're going to
yeah.
be excited to know. But
No spoiler alerts.
that's right. So, really, can you preserve the energy, strength, and mental sharpness of someone who may be decades younger?
Yeah,
Right.
and perhaps even more importantly, what are the practical ways to maximize the energy equation in your own life?
Mhm.
And we got a lot to talk about today. We've got tons of chapters, and we may not get through it, but we want to have fun. So we're not going to press ourselves for time. We've got 1 hour, and we hope you can sit back and enjoy this. And if we have to split it into two podcasts, well, dang it, we'll just do that.
We absolutely will. We're not afraid to do that, are we, Dr. Mark?
Not at all. No, we are windbags.
So, you want to move to chapter one? What is energy? How about that?
Yes. And here's where we kind of divide it into different buckets, right? Because I feel like energy is not just one thing. Maybe strictly you can define it as that, but we're going to talk about physical energy, mental energy, cellular energy, right? And those things I think are, we can describe scientifically what's happening with those.
Mhm.
The other two maybe are a little difficult to describe scientifically, but we'll give it a shot. And that's perceived energy, so more sort of the mental energy, and emotional energy.
Yeah. And Dr. Mark, we're going to make some important distinctions today as well. I mean, we're going to, kind of show everyone where energy is not motivation, and energy does not equal mood, and energy does not equate to sleepiness or the lack thereof. And so I think we're going to answer this other question. Like when somebody says, I'm tired, they really may mean very different things, right?
Yeah, tiredness kind of means maybe I need sleep, right? And that's maybe a little bit different to the energy that we're talking about tonight.
Mhm.
Maybe tired means I'm emotionally drained or I'm not motivated.
Yeah. Or maybe it means, from the nutrition perspective, my body literally doesn't have the fuel that it needs.
Yep.
So,
So tonight we're going to mostly focus on that last one, right? The biology of physical and mental energy production. Now, to be fair, if you're unmotivated, that may not be a mitochondria problem. It may involve things like dopamine burnout or emotional stress. If you're emotionally drained, that may be more of a mood or a mental health issue. And if you're sleepy, that may be a sleep debt or a circadian rhythm issue, right?
mhm.
So sometimes the problem isn't that your batteries are dead, right?
Yeah, sometimes you just don't want to get off the couch, and really those are not the same biological problems that we've been discussing. So,
Yeah. Maybe it's just your spouse is exhausting you.
well, or maybe it's your spouse, maybe it's your kids, maybe I mean there's a lot of things, right? Maybe it's a combination of things as well. So,
Yeah. And
um,
those are important, right? But maybe they're the topics for future podcasts. But tonight, let's focus on the machinery of energy itself, right? So what it
yeah.
is. And here's some really interesting statistics. About 1 in 3 adults report frequent fatigue. And
Mhm.
about 13.5% of US adults say they feel exhausted or very tired most days.
Yep. I wonder why that is, Dr. Mark. I mean, if you look at those statistics, and I realize that there's self-reported statistics, right? And it's very subjective, right? It's very difficult to objectively measure what fatigue is. But I mean, in your mind, what do you think really causes 33% of the population to be fatigued?
Yeah. Well, let's go through it. I hope the statistics are better here, but hopefully, if even if so, by the end of this podcast or this and the next chapter, you'll figure it out and maybe try to improve things. So let's talk
Yeah.
chapter 2, bioenergetics. Now, this is
Mm,
this is a topic that I love, bioenergetics. So what I mean by that is sort of the biological energy equation, right? So many of you
yeah.
probably know how, I don't know, electricity is generated using natural gas or coal or nuclear energy. Consider your cells as maybe each cell in your body as a city. And in that city, you have multiple power plants called mitochondria. Interestingly, these mitochondria, there are hundreds in each cell. And actually, I one time looked at a stain. This is a live cell that was stained for mitochondria. So the mitochondria appeared green.
Mhm.
And in the cell, you could see hundreds of these little green, almost look like worms, and they weren't just sitting there, they were moving around.
Yeah.
So these were believed by biologists and cell biologists to have been maybe this union of a particular sort of a prototypical cell that combined with a primitive cell and then sort of enjoyed a happy sort of coexistence. But either way, these mitochondria are the power plants, and they are generating energy for your body. It's pretty interesting stuff. And what is that energy currency? What is that that we have?
Yeah,
Well,
the energy currency of the cell is actually a compound called ATP or adenosine triphosphate.
right? Yeah.
Yeah,
So maybe you could just call calories crude oil and ATP is like refined gasoline, right?
absolutely.
Now, I'm going to say something really crazy here. Let's dig into it a little bit. Where ultimately does all biological energy come from? And maybe even actually you could say, by extension, all energy on the earth comes from one place.
The sun.
Yeah.
It's
I mean,
amazing, isn't it?
that's a crazy thought, but let's dig into that a little bit. My
Yeah.
master's was actually the path of carbon in photosynthesis.
Mhm.
And I was studying one enzyme for the most part. Well, there were several enzymes in the pathway, but the key enzyme is a protein, an enzyme, same thing, called rubisco, ribulose bisphosphate carboxylase oxygenase.
Mhm.
That enzyme is the enzyme that is key and the only enzyme that it can actually take the light from the sun and pull in carbon dioxide from the air and turn it into sugars, right? So
Mhm.
it has a 5 carbon sugar that's inside the cell, and ribulose bisphosphate carboxylase oxygenase, Rubisco, is able to connect carbon dioxide to that 5 carbon sugar phosphate and make 6 carbon sugar. And from there, every molecule and every um, molecule that produces energy comes from. I mean, that's a
Wow,
crazy thought, isn't it?
that is a crazy thought. Yeah, and the sunshine is so powerful and so beneficial, and of course, you can overdose on sunlight. We all know that, right? But one of the things that I will say about sunshine and our bodies, Dr. Mark, and I tell people this a lot, especially people that we work with that might have some type of a mitochondrial dysfunction, or they do feel very tired. They do feel really sluggish. In fact, a lot of times I will tell you this, when I feel really, really sluggish, I can go lay out in the sun for about 15 minutes. And here's what I determine is the optimal length of time for me. When I can lay out in that sun and get sun on my back, sun on my front, whatever. But when my body starts to tingle, I know that those mitochondria are taking that sunlight, the UV rays from that sun, and they are becoming active and they're producing ATP and they're producing energy. And I can tell at that particular point, as soon as I start to tingle, it's time to get up. It's time to
Huh.
get out of the sun. I've activated my mitochondria. But that sunlight is so powerful that people will learn to use that. And again, the tingling of the skin is the point to where they are maximally energized, and it works beautifully.
Yeah. Well, just to be clear though, plants are the only ones that have these little chloroplasts that have sort of the equivalent of kind of a mitochondrial sort
Right.
of structure.
Right.
They're the only ones that can pull the energy from the sun in the form of these, in the form of sort of fixing
Yeah.
carbon dioxide, right?
Right. Right.
And
Right.
but let's extend that a little further. What about oil? What about the stuff that we dig out of the ground? Like that didn't come from the sun, did it? Or did it?
Mm. I think it did actually. Yeah.
Yeah.
I
Yeah.
think I think the term fossil fuel, and this is an argument that I've had with a lot of people that don't really understand fossil fuels. The earth makes its oil. They are not, quote, fossil fuels. They're not derived from dead dinosaurs. I mean, let's get that out of the way right now.
Well,
That
uh, the yeah, there's an argument that a lot of energy, though, does come from organic matter, right? Coal
right,
is
right.
definitely organic matter. Oil, from shale and coal, maybe organic matter. I don't know where else it comes from, but definitely I see that this Earth, the sun, creates a ton of energy, and without the
Yes, it
sun,
does.
there would be no life, right?
Yep.
Yeah,
That's right. You're exactly right. That sunshine is the key to all life, no
yeah.
doubt.
Yeah, so that
So,
that fixing or pulling of the carbon dioxide out of the air by Rubisco. And by the way, let's ask another really fun fact. What is the protein that takes the how do I say it? The combined weight of that protein is the biggest protein on the planet. It's not cows, it's not insects. That's a lot of insects or a lot of biomass. But that enzyme, Rubisco, is the most plentiful protein on the planet.
mm,
It's just
no
like we've got
kidding.
these little factories all over the earth. Everything that's green, that is harvesting energy from the sun and creating ultimately food,
Yep.
glucose, fats, amino acids, and all of the biochemistry in our body enables us to process that and turn it into energy, right? Okay, this is something really fun as well. Your body, those mitochondria, what happens when you eat food? Right? There are processes in the
Mhm.
body, fascinating processes in the body where basically the body turns that food into reducing equivalents or protons,
Yep.
like hydrogen ions. And those are kind of stuffed into the inner membrane of the mitochondria. And they form basically what you call a proton motive force. It's kind of like a hydroelectric dam, right? Imagine the energy of all that water behind the dam, and you can let it out and push it through a turbine.
Mhm.
Well, that's what's happening in your cell. You have this proton motive force. You've got all these protons that, eating food and the citric acid cycle and all those things and reducing equivalents are generated. And then those enabled, in order to get out of the mitochondria, they have to push their way through an enzyme called ATP synthase, right?
Mhm. That's right.
It is literally like we've done electron microscopy on these guys. They look like little windmills, like little turbines. And when the protons go through that turbine, it spins at 100 revs per second. And it basically mashes ADP with a molecule of phosphate and produces ATP. Is that not crazy? It's actually kind of like this little nano pump, and they're all over the mitochondria. This is what happens as a result of eating food that eventually creates this energy storage form for your body, kind of like a battery.
Yep. Yeah, when you think about it, and really this process takes place inside the mitochondrial matrix, right? And it utilizes, you talk about food, and then you got glucose, fats, amino acids, how that's broken down, and it's broken down into this one compound called acetyl CoA, Dr. Mark. And whether it's glucose or fats, now amino acids are a little bit different, right? Amino acids are not really a preferred energy source. Although we do have some amino acids that are considered gluconeogenic, they can be converted to glucose, and then the glucose is, of course, converted to acetyl CoA, where then that acetyl CoA is converted to NADH, FADH2, and then GTP, ATP, CO2. So you've got this process where food basically gets converted to acetyl-CoA. But there's some really cool differences between glycolysis of glucose and beta oxidation of fats or essential fatty acids, right? Or like a carbon 16 fat. There's some really significant differences in what those two compounds produce as far as ATP. It's pretty neat.
Yeah. Yeah. Here's a couple of other snippets for you. We're just going all over the place here, but we kind of love the biochemistry. Okay. So,
Yeah.
why do we breathe oxygen? Oxygen becomes the final acceptor for electrons along this little thing called the electron transport chain along the
Yep.
membranes of the mitochondria. And there's a couple of interesting snippets here. When you smoke a cigarette, nicotine from that cigarette actually disrupts that electron transport chain. It disrupts the generation of energy. This may be why, if you smoke, it's a little harder to store excess energy. You tend to be a little thinner if you're a heavy smoker, right? Not always, but there's definitely a case for that. Maybe that was even a prescription back in the 60s, right? Yeah, if you want to stay slim, smoke. Another interesting snippet is the poison from the poison arrow. I mean, the poison frog. You know, those little frogs in South America, and they use the poison on their skin with arrows that stun the prey. That actually prevents oxidative phosphorylation. So again, that inhibits the energy from the mitochondria and can actually paralyze. So it's interesting. It's like a hydroelectric dam, and each cell contains hundreds of these mitochondria. Here's another interesting statistic. The brain uses about 20% of the total body energy, even though it's only about 2% of your body weight. So your brain consumes a lot of energy and needs to generate a lot.
Yeah. And we learned a couple of weeks ago, and I'll ask this question. Let's see if our people actually remember this. What uses the other 80% of postprandial glucose that comes in after a meal? What
Well,
organ uses the other approximately 80%?
yeah, anyone here? Anyone? You feel free to chime in if you're a live audience. Hopefully, you know that the muscle, right? The muscle is something that consumes most of that glucose, contributing
That's
to
right.
healthy metabolism.
So how about that?
Okay.
Between the muscle and the brain, Dr. Mark, the muscle and the brain utilizes about 100% of our energy. That's pretty
Yeah,
crazy.
that is. It's amazing.
So,
So the bottom line there is like, even if you're not a biochemistry nerd like us, there are some amazing gymnastics that go on in the cell of a plant that actually basically harvest energy from the sun and from the air, the CO2. And then in the human being, as you absorb that food, as you break it down, the body is able to do amazing things to turn that food into ATP, which is the storage form of energy that the brain uses, a whole bunch of it, and that your body uses. So you're probably curious. Let's go into chapter 3, how food becomes energy. So when we talk about food, Dr. Allen, what is food? Like, what are the major sort of macronutrients? I
yeah,
think our
well, I
audience
mean,
knows this, but let's go over it.
yeah, I mean, you basically have your carbs, which are kind of your fast fuel. And then you have your fats, which are more slow burning, dense fuel. And then, of course, protein. And we talked about it a while ago. It's more structural, but it's more of a backup fuel in case of emergency, call protein.
Yes.
So,
Yep. And all those macronutrients, right, are sort of I guess, like the logs that you put on the fire. But
yeah.
what is the fire? And what we want to say here is that you have to unlock that energy somehow. So
Mhm.
you have to break down those macronutrients. And how do you break down the macronutrients? It's enzymes, right?
Mhm.
So what are
Yeah.
enzymes? Give us a quick definition for everyone here. What's an
Yeah.
enzyme?
Enzymes basically are, things like proteases, catalases, carboxylases. I mean, there's so many different lipases, which are responsible for breaking down fats and so forth in the body. But these things are actually they attack these long chains of, it may be carbohydrates, and they break these chains down, or it may be long chains of proteins, right? And break them down into peptides and amino acids, or long chain of fats and break them down into essentially carbon units, and basically prepares our food for conversion to ultimately ATP.
Yeah. So we talk a lot here about protein, right? And so the DNA really is a blueprint for proteins. That blueprint tells the body exactly what the order of amino acids is going to be in that protein. And that order of the amino acids then tells basically instructs how that will fold.
Yep.
And so we've talked about peptides, which are fragments of proteins that have a specific sequence that can unlock receptors, right? But then you have larger proteins that fold. They can be structural or they can be globular. And that's really what enzymes are made of. So these globular proteins that fold in a particular way, and just imagine them like a Pac-Man, and they're all a little bit different, but a Pac-Man, and maybe that little Pac-Man has no teeth, but this is a globular protein with an active site. And so you described, Alan, these enzymes of catabolism, right? Meaning enzymes that break things down. And there are hundreds of different types. So just imagine all different kinds of fish and sharks that are swimming around, and they each have their favorite food. They're able to break down proteins or carbohydrates or fats in a very specific way. Mm-hmm. So these are all the catabolic enzymes. And you could call another word for them, you might say, is a catalyst.
Catalyst, yep.
Yeah, because they enable reactions to proceed that normally would not proceed. Yep. So let's imagine, for example, that you have a bowl of thick soup. Maybe it is clam chowder. And it can sit and be fairly thick, especially if you've used a gelatin thickener or something, right? And it sits in that bowl and it's quite thick and quite rich. And let's say you contaminate it. Maybe you take a spoonful, put it in your mouth, and then you put that spoon back into the clam chowder and you leave it for a while. Do you know what happens to that clam chowder?
Liquefies.
Yeah, it does. It gets really thin. You go, what the devil just happened to my clam chowder? Well, I'll tell you what happened to the clam chowder. You've got enzymes in your mouth that are really good at breaking down carbohydrate chains and protein chains, and they contaminated the soup. And those enzymes went to work catalyzing. And what that demonstrates there is, like, it would take a long time for that reaction to happen and for that soup to break down into sort of something watery. It would take a long time on its own, maybe 100 years. I don't know, maybe longer, maybe less. But those enzymes speed things up. And so those enzymes in your body are breaking things down. There are also enzymes like Rubisco that build things up, right? So those are anabolic. You could call those basically enzymes that are part of anabolism, or building things up. So when you eat food, those enzymes go to work. But here's the thing. They can't work unless they have a cofactor. So I mentioned that those proteins have no teeth. The teeth are micronutrients. So you've all been wondering, what the devil do these B vitamins, and what does vitamin C do, and what do these metals do, like selenium and copper? Well, they are cofactors for the enzymes. Without them, as they complex into the active site of the enzyme, they enable the enzyme to work as a catalyst, right? Give us some examples, Dr. Jones.
Yeah, some, like vitamin B1, for example, is basically a precursor to pyruvate dehydrogenase, which pyruvate dehydrogenase is responsible for one of the conversions of pyruvate to ATP. And you've got vitamin B2, which is a precursor to FAD, FMN, and helps with that conversion of FAD, FMN in the whole Krebs citric acid cycle as well. And then you've got B3, NAD, NADH.
Yep, the B vitamins in general are just famous for being the enzymes that work the cofactors that work with enzymes that break down food and turn it into energy, right?
Absolutely. Yep. Vitamin B5, vitamin B6, vitamin B12. Yeah.
Yep.
All of them.
That's why when you are low in B vitamins, you often feel lack of energy. So there's a really good secret, right? those B vitamins are actually very heat and light sensitive. If they're
Mhm.
exposed to light and heat, those enzymes kind of die off. And your body needs to replace them regularly. So you need to eat food that's rich in these B vitamins.
Yep. You know,
Hey,
some other important.
we got a question from Carmen.
Yeah.
She said, if you're lactose intolerant, is that an enzyme deficiency? And the answer is yes, that's right. So there's an enzyme called lactase, right, that breaks down lactose. Lactose is milk sugar.
Yep.
And especially in Asia, the Asians are generally very low in lactase. So pretty much once they're weaned, genetically, Asians then become sort of intolerant to milk, much more so than those of European descent. But even a lot of people of European descent end up sort of losing that lactase. And that may just be because, well, you've got the genes for it, but they're not being expressed anymore as you get older.
Mhm. Yeah, Dr. Mark,
And
I had a
yeah,
I'm sorry, just a little story about that. I
yeah,
had a little experience with lactose intolerance as I've gotten older. I used to drink when I was growing up. Of course, you know, when you're living and working on farms and stuff, milk is a staple in your diet, and I would not be, um, you know, it would not be uncommon for me and my two brothers to go through a gallon or 2 gallons of milk in a day pretty easily when we were growing up. And as I got older, I started having these problems with reflux, and I didn't know what it was. I was probably in my mid 30s, and all of a sudden I would drink milk and like my jaw would start locking up. And I literally, as I got older, became lactose intolerant. I think a lot of that probably had to do with the amount of milk that I drank when I was a younger kid. I mean, it just was crazy about how hard it hit me because I used to get up and drink a big glass of milk every single day. It's how I started my day. But it got to where I couldn't do it anymore. And I haven't had a glass of milk in a long time other than just a little bit of raw milk occasionally,
yeah.
but
Well,
not
I
something
think
I.
you're not unique, but then again, not everyone's the same, right? So I
Right,
have
right.
my son-in-law, his family are just huge milk drinkers, and they have been all their lives. And even as an adult, my son-in-law, who's nearly 50 now, drinks a ton of milk, and I do as well. Like I love to drink milk. It's a great source of protein. There's 8 grams in every cup.
Yep,
So I'm glad that I can still digest it quite nicely. But definitely, maybe there are certain events or it's just certain background genetics. But once your body decides not to make it, I guess you're kind of out of luck. And you can take oral enzymes to help.
right.
But the bottom line is here again. I think what we're trying to emphasize is that there are enzymes that require cofactors to
Mhm.
create to basically break down the food and make energy. And the B vitamins play a big role there. There are others like iron and magnesium. They're important because, like magnesium, for example, is part of that um, ATP synthetase. It's part of that structure there. Without magnesium, that ATP cannot be produced by that enzyme. And if you start to really get a deficiency in magnesium, you'll have major fatigue issues. They call it magnesium deficiency tetany. So it's almost like a tetanus kind of problem. So CoQ10 is another one, right? There's a that's a cofactor for the electron transport chain.
Yep,
So what's the bottom line here? If you want to have good energy, you don't want to be marginally deficient in some of these simple micronutrients that are sort of part of a healthy diet.
yep,
And me, I take an insurance policy every day. I take a simple multivitamin that provides sort of RDA levels of these B vitamins and iron and magnesium and CoQ10, things
mhm,
like that. In the US, if you're eating meat, you probably don't need an iron supplement. Just to let you know, you're probably getting plenty of heme iron that's doing the job for you.
yep. You know, Dr. Mark, another very important nutrient that we haven't talked about yet is L-carnitine as well. And especially when you start talking about, you know, beta oxidation of fats, how important L-carnitine. In fact, L-carnitine as a nutrient is kind of the rate limiting gate for fatty acid oxidation. And the reason is because without L-carnitine, the fatty acids cannot be transferred across that inner mitochondrial membrane without the presence of um, L-carnitine, converting it to acyl-carnitine, or in this particular enzyme, it's called carnitine palmitoyl transferase 1, CPT1. So
Yeah.
yeah, so L-carnitine is another incredibly important amino acid in this particular case that is vital for fatty acid oxidation.
Yeah. Now, what's your advice there? Do you need to, is this a vitamin or does your body produce this?
Well, so L-carnitine is an amino acid.
Yep.
It's not considered an essential amino acid. However, we get a lot of it in our diet. It typically comes from red meats. Red meats very, very high in L-carnitine, or other types of meat sources. So if you're a vegetarian or a vegan, I would strongly recommend that you take an L-carnitine supplement, because I think that there is a chance that you're going to be on the low side of L-carnitine if you're a vegan or vegetarian. If you're
Yeah.
a meat eater and consuming optimal levels of protein, you're probably good on your L-carnitine. Although, we feel strong enough about L-carnitine that we include it in our lean formula, because it is incredibly important to get those fats into the mitochondria where they are burned and converted to energy.
Yep.
So,
Yep. Not everything is like cut and dried in biochemistry and human nutrition. So
right.
carnitine is, as you said, an amino acid. It is conditionally essential, right? Meaning that
Yeah.
often
Right.
your requirements exceed the individual's ability to synthesize that nutrient, right? So under certain conditions. So
Right.
it's not a bad idea to supplement with it occasionally, right?
Yep. So,
Yeah. All right. So there you go. Make sure that you are eating a healthy diet. This is part of the reason why. And I take a multivitamin just sort of as an insurance policy. And, that's going to help if there's fatigue that's related to marginal deficiencies in nutrients. And it definitely happens. So keep that in mind. Okay. And that's part of the biochemistry. It's part of why we shared all that with you. All right. This is not your mother's podcast, is it? We get real complicated sometimes.
yeah.
Okay, let's go to chapter 4, and this is muscle, right? And let's talk about how muscle relates to fatigue, or the lack of fatigue, your energy levels. So this is a really strong area for Dr. Allen. You've already mentioned, Dr. Allen, that muscle is a glucose sink,
Mhm.
right? And so this is great. It's helping to keep a healthy metabolism, and we'll talk about sort of how important that is. But why would you describe the muscle as we've talked about mitochondria. What's the
Mhm.
relationship between muscle and mitochondria?
Well, there's a couple of relationships between, and it's definitely a bidirectional relationship when you start talking about muscle and mitochondria. Muscle, as we exercise and as we work that muscle, as we contract that muscle, we actually induce mitochondrial biogenesis, which means that we increase the number of mitochondria found in our muscle. That is very important when we start talking about energy levels. And we'll touch on that a little bit, about how exercise actually increases energy. It sounds like that can't be the possible, because exercise should exhaust you, but some of the second order and third order consequences of exercise will lead to an increase in energy. A big part of that has to do with mitochondria. But the other side of that is, without mitochondria and without mitochondria functioning properly, Dr. Mark, our muscles are not going to function properly. So that bidirectional relationship between muscle and mitochondria is incredibly strong. So yes, it's a mitochondrial reservoir, but it's also a way to generate more mitochondria and more energy as well. So,
Yeah, it's kind of like a mitochondrial reservoir. I love that.
mhm.
And so that's, I mean, it just seems to me that uh, I know it's telling me something that I mean, I'd rather have more of these little energy generating um, cellular
Engines.
particles
Yeah. Yeah.
than less, wouldn't you?
Oh yeah. Yeah, when we when we start having fewer mitochondria, ultimately leads to some long term problems. So, We want to make sure that we're preserving and building strong mitochondria all the way throughout our entire lifespan. No question.
Yes,
Good.
that's great. Okay, let's talk about something that is one of your favorite topics, I think,
Mhm.
right? And we've talked about myokines before, but and so describe those for us again, basically,
Mhm.
and if you can, and if it's true, how would these myokines relate to energy and your, lack of fatigue? Let's put it that way, the energy that you might experience day to day.
Well, okay. So first off, what myokines are little chemicals that are secreted by muscles. And there are really two different types of secretions. There's a specific myokine secreted from sedentary muscle, which we do not want. That's called myostatin. But then there are a number of other myokines that are secreted from exercising muscle. In fact, about 600 plus that have been identified. We don't know what the actions are of all of those myokines, Dr. Mark, as we know, but we do know that they're the actions of several of them and how powerful those myokines are. What we
Yeah.
also know is that muscle is an endocrine organ because of myokines. These myokines impact every other organ system in the body in a very, very positive way. And so, if we can capture the power of myokines through the right types of exercise, then we can benefit literally every organ system in our body.
Yep. And
So,
we've described these before. These myokines are, this is the peptide connection, folks. These are your endogenous peptides. And I'm going to use the definition a little more loosely because some of these are larger peptides and may be considered proteins, but they are messengers. And so
yes,
they are communicating. And it's so funny because for years and years and years, for hundreds of years, we've known, or maybe for 100 years, we've known that the thyroid is an endocrine organ, that the pancreas is an endocrine organ because it produces insulin and glucagon, right? And these are helpful little endocrine organs, and endocrinologists are a special branch of medicine that deal with sort of endocrine systems in the body produced by these different endocrine organs. And
Mhm.
all these years of modern biochemistry and physiology, the humble muscle has been sitting back and saying, what am I, chopped liver? Well, they're literally not chopped liver, right?
Yeah,
But they've been saying to us, I've got a vocabulary of over 600 different peptide hormones and messengers. Like
yeah,
that pancreas has just got two or three. I've got hundreds. Why aren't you calling me an endocrine organ? So it's pretty
yeah,
interesting that it's really only in the last 20 years, even less, that
yeah,
we have suddenly recognized the muscle to be this very powerful endocrine organ. And it's starting to answer all these questions that we've had for years and years. It's like, why is there such a strong relationship between muscle and healthy metabolism, and muscle and aging, and
yeah,
muscle and brain function, and muscle and bone strength, and muscle and the cardiovascular system health? So
yeah.
now we're starting to see this question answered, and it's all through that magic little peptide series of molecules called myokines.
Yeah, it's going to be really exciting. I mean, really, like you said, 20 years, really within the last 10, we're just now
Yep.
starting to understand these. We haven't even identified the actions of all of these 600 that we've identified. They're identifying more all the time. So this 600 just continuously grows. But when you think about how healthy muscle helps to improve insulin sensitivity, how does it do that? It does it through myokine communication. Or how does it improve metabolic flexibility through myokine communications? How does it improve energy production through myokine? Because it's certain myokines that actually induce mitochondrial biogenesis, right? So we're producing more energy. But it's so amazing how muscle impacts all these other systems. And we're just now learning. And we've been studying the human body for hundreds and hundreds of years, and we just now figured out that muscle is more than just structural.
Yes.
So, what are we going to figure out in the next 20 or 30 or 40 or 50 years? That's where it's going to be pretty cool.
Yeah. And I think they're going to double down and learn a lot more about the importance of muscle. When
Yeah,
muscle moves, the body listens. And what I find
absolutely.
interesting is that the brain listens. So we've been talking about energy tonight. And you look at the muscle, and it is the epitome of the expression of energy, isn't it? Your muscles are moving, it's power, it's movement, it's speed, and a lot of other subtle things. But also, when our muscles move, then part of that expression of energy is actually through our brain, that feeling of being energized. And I've no doubt that that comes through some of these enzymes, some of these peptides like BDNF, right, which we know is a
Yeah.
neurotropic factor. So literally, this is a peptide that kind of wakes up the brain, increases neuroplasticity and memory. But there are other things that indirectly wake up the brain and give you a feeling of energy. And that is that the, again, myokines from the muscle and the ability of the muscle to be a sink, a metabolic sink for energy and sugar, actually creates a healthy metabolic environment. Now, specifically, let's just talk about inflammation. Inflammation is kind of like a dysfunctional metabolism.
Yeah.
If the muscle movement, if the myokines from the muscle actually help to calm that, create a healthy metabolic environment and lower inflammation, what effect does that have on the brain that we know of according to modern biochemistry and neuroscience?
Well, we know that inflammation is totally destructive to brain, right?
Yep.
And when you start talking about that, now you're talking about dementia, you're talking about, very significant diseases that are caused by inflammation. But we also know that things like Alzheimer's, Dr. Mark, are now being referred to as diabetes type 3, right? Which is a very significant and very important factor because guess what we do know that can impact diabetes and, again, the utilization of glucose in a very positive manner? It's muscle. And how
Yep.
does that muscle use those myokines to talk to our brain? It reduces that inflammation. It convinces our brain that glucose can be used for energy. I mean, muscles do so much to impact our brain health.
Yep.
And I'm not sure I answered your question there, but I
No,
think
I
I
think you
kind of went
did.
off
Yeah.
of a tangent. So
It was a great tangent. Yep. That stability and healthy metabolism all over, including reduced inflammation, systemic inflammation, helps the brain directly, right? The brain becomes kind of dysfunctional under oxidative stress.
yeah.
And it's really incredible how the muscle can help sort of buffer that.
Yeah. Well,
Yeah.
and inflammation also causes it's one of the most significant underlying causes of fatigue as well. Because when your body is constantly fighting inflammation, as an immunologist, I mean that just hyperacts or makes your immune system just hyperactive in trying to fight that inflammation. And that inflammation, if we can find ways to start to lower that inflammation and reduce that systemic inflammation. For example, the 8 amino acid peptide that we have in our product Fit, that is an anti-inflammatory peptide. And it has been shown to tremendously reduce inflammation. And we've seen time and time again where that reduction in inflammation actually leads to better energy levels in people, feeling much, much better. I just had a conversation with one of our affiliates just a couple of days ago talking about, and she was just blown away by number one, how good she felt, but number two, she used to sleep for like 10 to 12 hours a day because she was exhausted, tired all the time. And now all of a sudden she feels better. I think it's because we've reduced her inflammation to a point now to where her body's not having to fight it so much all the time, that she has more energy and she's getting the same benefits of, 6, 7, 8 hours of sleep at night as she was when she was having to sleep for 11 or 12 hours a night.
I love that. So,
Yeah.
so here we're talking about muscle is this amazing metabolic shock absorber. It's creating a healthy environment for not only just for energy production, but also for the feeling that you get when you're energized, right? So
Yeah.
there's definitely a brain connection there to the energy that you feel. We also introduced this idea that it helps in that context of healthy metabolism, reduce systemic inflammation, which is really important for energy feelings as well, right?
Mhm.
And so you've talked about this term myosteatosis
Yeah.
before. So now we're talking not just about muscle and how much you have, but the quality of the muscle.
Mhm.
So tell us a little bit about this, and again, in the context of energy.
Well, so myosteatosis is essentially when we lose muscle, we allow fat to infiltrate into those muscular bundles now. Okay. And so we're essentially myosteatosis is essentially the replacement of muscle with fat. And it can happen intramuscular, intramyocellular. I mean, it's significant. And what it does is it reduces the density of our muscles, which guess what? When we're reducing the density of our muscles, we're reducing the number of mitochondria that we have in our muscles because we're impacting our metabolic resilience, our metabolic flexibility, our metabolic fitness when we're replacing muscle with fat. So
Yeah.
that's what essentially myosteatosis is. And it definitely leads to low quality and very dysfunctional muscle.
Right. Getting that beautiful V8, turning it into a lawnmower. Not a good thing. I actually saw
Yeah.
a recent.
Well, you want to
Go ahead.
go ahead, Doctor. I'm sorry.
Oh, well, I just saw a recent study that came out, right? And it's there are ways of imaging the body, sort of doing a cross section through the body through
Yep.
DEXA scans and things like that. And they did a study of women that were eating ultra high processed foods, sort of as their normal diet, versus those that were eating a normal diet. And I don't know what's normal anymore in America, but basically you had healthy versus someone eating a lot of ultra high processed food. And they looked at cross section of the muscle right through the leg, through quadricep area, right in the upper thigh. And they showed that the ultra high processed food diet led to massive myosteatosis, right?
Yeah.
It looked like that meat looked like the kind of steak that you would really enjoy, like that fatty grain fed steak. It did
Yeah.
not look like lean muscle at all. What does that do to the energy output of that person?
Oh, it decreases it tremendously. I mean, when you're replacing your muscle with fat, and if you want to know what that really looks like, go to the meat market. Like we have these stores down here called HEBs, and HEBs have these marvelous meat markets, and you can go and you can get grass-fed beef, you can get grain-fed aged beef, you can get prime beef, and you can get Wagyu. And if you want to go see an example of what myosteatosis is, go look at a Wagyu ribeye or a Wagyu New York strip, and you'll see all of that fat infiltrated within that muscle fiber right there. And look and see how that compares to a grain or a grass fed steak. Dr. Mark, they're night and day. But if I'm talking about steaks, I definitely want to have a Wagyu steak because they taste phenomenal. But I could promise you that a Wagyu beef is not going to be near as high performing. A Wagyu cow, I should say, is not going to be near as high performing as a grass fed cow because that grass fed cow has got some muscle now,
Right.
some high
All right.
quality muscle.
So we're talking here about energy,
Yep.
and here the context is that muscle is the engine, and there's healthy muscle, there's unhealthy muscle. I guess our goal then, I think, is to make sure that we take care of our muscle, which means resistance training, means movement. And as we do that, our energy will increase. And
Mhm.
also, what we eat, we have to be really careful. We have to make sure that we don't sort of become, do you call it myosteostatic? I don't know what to call it.
That's a pretty good description of it.
Yeah.
Yes.
So let's not be that. Now we've only got a few minutes left, and I just want to like tease this next concept. Obviously, we're going to have to break this podcast into chapter 2 or podcast number 2 to finish this. But just let's briefly sort of talk about this paradox. Chapter 5, why movement creates energy. And the
Mhm.
paradox is like, why is it that if you exercise and you move, instead of being more exhausted and feel less energy, actually ultimately that creates more energy? And Alan, outline it briefly for us. We probably don't have time to go into this chapter completely, but we'll continue it in the next podcast.
Well, again, we talked about mitochondrial biogenesis. You're having more mitochondria that you're building into your muscles. Guess what? You've got more energy producing capability in those muscles. You're going to have more ATP. You're going to have more energy.
That's
But then on
because
top of
your body is responding to the movement, right? By
that's
saying,
right.
hey, if you're moving, then I'm going to build more of these energy factories for you. I'm going to build the
Yeah,
infrastructure for you so that you can continue to do this, right?
that's right. And if you look at that in contrast to sedentary lifestyle, in a sedentary lifestyle, we actually get rid of mitochondria. We get rid of our body's ability to produce energy because we don't need it. Not only do we get rid of that, we get rid of our muscle because it's metabolically very expensive, Dr. Mark, as well.
Right, exactly
So
the opposite is happening, right? Your body's
yeah.
saying, "Well, you don't need it, and it looks like you're not moving, and this
Mhm.
is energetically expensive to keep, so I'm just gonna break it down."
Yep, that's right. That's right. The next thing that movement does is it increases blood flow, which increase in blood flow means we've increased our oxygen capacity in our body, our what they call VO2 max, right? So we improve our VO2 max. We increase nutrient flow that is carried through the body in our blood. And there are a number of benefits by increasing circulation. We also, I think, we benefit our cardiovascular system by increasing that blood flow and increasing that circulatory capacity as well.
Yeah, and let's not forget movement increases myokines, which we just talked
Mhm.
about.
Sure does. It sure does.
And
It
that's the
also,
feeling of energy that we talked about, right? So there's the paradox explained as well. You're moving, now your muscle is talking and it's
yeah,
talking to your brain. And so interestingly, rather than being exhausted, the muscle moving is actually ultimately saying to your brain, that's a good thing. I feel
yeah,
energetic.
I feel good. I feel good. That's right. Insulin sensitivity is another thing that exercise improves. And we improve our insulin sensitivity. Guess what we prevent at that particular point? You
Yeah.
know, metabolic issues.
Yeah. Okay. So running out of time. So we'll continue this because it's a fun discussion. But we defined in chapter one what is energy, right? Physical energy, cellular energy. Then in chapter two, we went into the bioenergetics, right? How the cell actually produces energy. And we covered there that cofactors are really important. So in chapter three as well, food becomes energy through these B vitamins and other cofactors. So you really need a healthy diet that's full not only of the macronutrients, but the micronutrients. Then we talked about muscle, how important that is. And we're just starting to dig into how movement creates energy. So let's continue the discussion next week where we talk about um, energy and immunity. So, what happens when you're sick and what happens to your energy levels? We're going to talk about stress and energy. So, if your body acts like it's under attack even when there isn't an infection, what does that do to your energy levels? We're going to talk a little bit more about the brain, about peptides, about that question that you asked earlier. Does energy have to decline with age? I sure hope it doesn't because I'm getting there. Let's talk about that. Then we're really going to break it open and talk about common deficiencies and hidden causes of fatigue and practical ways that you can build your energy. But I think we've got enough time for a couple of talk nerdies to me, don't you think?
I think so. Absolutely. We got 2 minutes. Let's get some out of the way.
Let me kick it off. I'm not saying I'm low in energy, but if someone pushed me right now, I'd stay lying down.
Dr. Mark, I'd go for a bike ride instead, but the bike is also too tired.
Wait a minute. What? Two tires? You know why that's confusing? It's because in America, they don't spell tire Tyre, they spell it Tire. I get it. I get what you did there. Mike is too tired as well.
Yep, yep.
All
So,
right, Dad, can you explain an eclipse to me? No, son.
no sun.
I guess he was too tired to explain the eclipse to
I
his
guess he was. I guess he was. I'm so tired, Dr. Mark. The rubber no longer meets the road.
Oh man, that's really tired. Uh, I wish we could talk more about energy, but hey, Alan, I told the doc the other day that I was so fatigued all the time. And you know what? He called me a liar.
What did he say exactly, Dr. Mark?
Well, he told me it was a fib. I think
Yeah,
that's a medical term.
I
Okay.
think that's a medical term for sure.
Well, guys, you've done it again. You spent another hour with us. I hope it wasn't too complicated tonight. But energy is such an important topic. You chose science over scrolling and cell signaling and myokines over cat videos. So, congratulations. Peptides over procrastination.
That's right. So now it's time to go make a difference, guys. And next week, come back and see us again where we're talking about more energy. But Dr. Mark, guess what? We're doing next week from
From Dublin,
Dublin,
Ireland.
Ireland. That's right. Dr. Mark and I and Brett, we will be in Dublin, Ireland for a series of meetings, and then we'll be in Barcelona, Spain for a series of meetings. And we've got some really, really exciting stuff that we're working on for you guys.
Yeah, so we'll do our best and we'll continue this part deux coming up. And,
Sure.
we know it was a little bit complicated today. So please, if you have any questions, send them to science@makewellness.com.
Yeah. You guys come
Bye-bye,
back and see
everyone.
us next week. Have a great week and weekend.